Hey everyone! In today's video, I'll be working through some of the hardest GCSE Maths questions of 2026. A number of these questions are taken from the Level 2 Extended Maths Certificate 2025 exams, as they fall within the GCSE syllabus. So if you're aiming for grade 9, then this video is for you, and without further ado, let's get started. So in the first part of question 4, we are told to simplify root 50. So root 50 can be written as root 25 multiplied by root 2, and root 25 is 5, so the final answer is just 5 root 2. In the second part of this question, we are told that by drawing a suitable triangle, show that sine 45 equals root 2 over 2. So the first thing we need to do is draw out our triangle, and I'm going to label this angle as 45 degrees. We know that this is a right angle, so this angle is 90, and this angle is also 45 degrees. These two lengths are 1, so I'm going to label the hypotenuse as x. And using Pythagoras' theorem, I can determine the value of x by taking the square root of 1 squared and 1 squared, and that gives me root 2. And using SOHCAHTOA, we can state that sine theta equals the opposite over the hypotenuse, so sine 45 equals 1 divided by root 2. And if we rationalize our denominator by multiplying the numerator and the denominator by root 2, we can state that sine 45 equals root 2 divided by 2. In the final part of this question, we are given a diagram that shows a triangle ABC, and we are told to work out the length of AB and to show all our working and simplify our answer. So using the sine rule, which states that sine A divided by A equals sine B divided by B, we can state that sine 30 divided by its opposite length, which is root 2 plus 4 divided by root 50 plus 1 minus root 18 equals sine 45 all over the length AB. And in order to simplify this equation, I'm going to cross multiply. So AB sine 30 equals sine 45 multiplied by the denominator, which is root 2 plus 4 all over root 50 plus 1 minus root 18. And given a sine 30 is a half, I'm going to write the left hand side as a half AB, and I'm going to set that equal to sine 45, which we've already obtained from the previous part of this question, as root 2 over 2 multiplied by root 2 plus 4, and root 50 we can write as 5 root 2 from part A of this question, plus 1 minus root 18. Root 18 can be written as root 9 times root 2, so we can write that as 3 root 2. So I can write this as minus 3 root 2. So a half AB equals root 2 over 2 multiplied by root 2 plus 4 all over 2 root 2 plus 1. And after we multiply both sides by 2 and rationalize the denominator of this term, we get this. So AB equals this. And after you simplify this, we can simply state that AB equals root 2 multiplied by minus 7 times root 2 divided by minus 7. So AB simply equals 2. And that's your final answer. In the next question, we are told that there are only green sweets, blue sweets, and red sweets in a jar. There are 14 green sweets. The number of blue sweets is 3 times the number of red sweets. 2 sweets are taken at random from the jar. Given that the probability that both sweets are green equals 91 over 561, work out the probability that both sweets are blue. So given as the number of blue sweets is 3 times the number of red sweets, I'm going to state that the number of blue sweets is 3n and the number of red sweets is n. This means that the total number of sweets in the jar is 14 plus 4n. We also know that the probability of picking 2 green sweets from the jar is 91 over 561, so this means that the probability of taking a green sweet and another green sweet is going to be 91 over 561. So the probability of taking a single green sweet is 14 divided by the total number of sweets, which is 14, plus 4n multiplied by the probability of taking another green sweet. Bearing in mind that the green sweet that was taken initially is not replaced, so we'd have 1 less green sweet. So in this case it'd be 13 divided by 13 plus 4n. and that equals 91 divided by 561. And after multiplying the two fractions on the left, we can then cross multiply to simplify this equation, and we get this. So 91 multiplied by 182 plus 108n plus 16n squared equals 102,102. And after expanding the brackets and setting this equation equal to 0, I get this. And after dividing this quadratic equation by 4, I get 364n squared plus 2,457n minus 21,385, and that equals 0. So in order to solve for n, we need to use a quadratic formula. So n equals 5, or n equals minus 11.75. And given as n represents the number of red sweets, n must be an integer. Therefore, n equals 5. So the number of blue sweets is simply 3 times 5, and that is 15. And the total number of sweets is 14 plus 4 times 5, and that is 34. So the probability that both sweets are blue equals 15 divided by 34 multiplied by 14 divided by 33. So the final answer is 35 over 187. In the next question, we are told that a bag contains only blue counters and green counters. There are more blue counters than green counters. A counter is taken at random from the bag, the color noted, and the counter is put back into the bag. This process is repeated one more time. The probability that exactly one of the two counters taken from the bag is green is 0.2112. Grace takes one counter from the bag. Find the probability that Grace takes a blue counter from the bag. So given as the probability that exactly one of the two counters taken from the bag is green is 0.2112, this means that the probability of taking a blue and a green counter, or a green and a blue counter, is 0.2112. So we can state that the probability of taking a blue and the probability of taking a green plus the probability of taking a green and the probability of taking a blue equals 0.2112. We can also state that the probability of taking a blue counter is x, and the probability of taking a green counter is 1 minus x. And using this equation right here, we can simply state that x multiplied by 1 minus x plus 1 minus x multiplied by x equals 0.2112. So x minus x squared plus x minus x squared equals 0.2112. And in order to solve this equation, we need to set it equal to 0. So if I move all the terms from the left-hand side to the right-hand side, I have 2x squared minus 2x plus 0.2112 equals 0. And what I'll just do really quickly is divide it by 2. So I have x squared minus x plus 0.1056, and that equals 0. And by using the quadratic formula, we can solve for x. So x, which is a probability of taking a blue counter, is 0.88. Before we get into the next question, if you like more support outside of these videos, make sure you join my Discord community, because that's where I'll be sharing extra questions and revision tips for GCSE, A-level and engineering math students. I also offer one-to-one and small group tuition, along with weekly live sessions where we work through exam-style problems together. Now, let's get right back to the questions. In the next question, we are told that ABCDEF is a prism with a cross-section in the shape of an equilateral triangle. The length AB is 30 centimeters and CD is 70 centimeters. G is the midpoint of AC, H is the midpoint of FD, and J is the midpoint of BG. K is a point on BE such that the ratio of BK to KE is 3:2. Calculates the size of angle JKH. So the first thing I'm going to do is label this diagram using the information given in the question. And given as we need to calculate the size of angle JKH, I'm going to create a triangle connecting the points J, K, and H. So angle JKH is this angle here, and I'll label this as X. Given as BK and KE are split in a ratio 3:2, we know that BE can be split into 5 equal parts. So BK equals 3/5 multiplied by 70, and that equals 42 centimeters. Therefore, KE can be obtained by subtracting 42 centimeters from 70 centimeters to get a length of 28 centimeters. The next thing we need to do is determine the length BG, because that will be used to obtain the length JG, which can be used to determine the length JH. So using triangle ABG, we know that AB has a length of 30 centimeters and AG has a length of 15 centimeters. So BG can be obtained using Pythagoras' theorem. So we have 30 squared minus 15 squared, square rooted, and that gives us 15√3 centimeters. So JG equals 15√3 all over 2. And using triangle JGH, we can obtain the length of JH. So JH equals the square root of the answer that we've obtained for JG, which is 15√3 over 2, all squared, plus 70 squared. And that equals 5√811 all over 2 centimeters. We can then work out JK by using triangle BJK. So we know that BK is 42 centimeters and BJ is 15√3 over 2 centimeters. So JK can be obtained using Pythagoras' theorem. So 15√3 all over 2 squared plus 42 squared equals 3 times √859 over 2 centimeters. And in order to determine the length KH, we need to use triangle KHE. And for further clarification, triangle KHE can be visualized if we look at this trapezium from the right. So if I draw a quick diagram, this should look something like this. So we have J, we have K, and we have H right here, and we know that this point is E, and by joining K and H, we get the triangle KEH. So we know that this length here is 28 centimeters. We also know that the length EH is the same as the length BG, which is 15√3 centimeters, and triangle KEH or KHE is a right angle triangle. So KH can be determined using Pythagoras' theorem, which will be 28 squared plus 15√3 squared or square rooted, and that equals √1459 centimeters. And now that we have all the lengths for triangle JKH, we can now obtain angle JKH using the cosine rule. And the reason we're using the cosine rule is because we have 3 known lengths and 1 unknown angle. So we know cos A equals b squared plus c squared minus a squared all over 2bc. So the angle can be obtained by taking the cosine inverse of the right hand side of this equation. So x, which is simply angle JKH, can be obtained by taking the cosine inverse of 3√859 all over 2, or squared, plus the square root of 1459 squared minus 5 times √881 over 2, all squared, all over 2 times 3√859 over 2 multiplied by √1459. So x equals 119.955677 degrees. And to one decimal place, that is 120.0 degrees. In the final question for today's video, we are given a diagram and the vector OA equals 2a and the vector OB equals 3b. OAB is a triangle, OAC is a straight line such that OC equals 4 times OA, N is the point on OB such that the ratio of ON to NB equals 2:1. P is a point on BA such that NPC is a straight line. Use a vector method to find the ratio of BP to PA. You must show all your work in. So the first thing I'm going to do is annotate this diagram using the information given in the question. And given as OB is 3b, ON can be obtained by dividing 2 by 3 and multiplying that value by 3b, and that gives us 2b. Therefore, NB can simply be obtained by subtracting 2b from 3b, and that gives us b. The vector BA can be obtained by going from B to O and O to A. So in this case, we have minus 3b plus 2a, and that can be written as 2a minus 3b. We know that OC equals 4a, so we can represent OC as 4 times 2a, and that gives us 8a. And given as NPC is a straight line, we can state that the vectors NP and PC are parallel. Therefore, NP simply equals alpha times PC. And the reason I am using alpha is to show that NP is a multiple of PC. And given as we are trying to find the ratio of BP to PA, and BPA is a straight line, I'm going to state that the ratio of BP to PA is k to 1. And so I can state that BP to PA equals k to 1. So the vector OP can be obtained by going to the vector OB and then from B to P. So the vector OB is 3b, and the vector BP is simply k divided by k plus 1 multiplied by the vector BA. And that equals 3b plus k all over k plus 1 multiplied by 2a minus 3b. We can also get from O to P by going from O to N and N to P. Therefore, NP can be obtained by subtracting ON from OP. So NP can be written as 3b plus k divided by k plus 1 multiplied by 2a minus 3b minus 2b. And that equals b plus k multiplied by 2a minus 3b all over k plus 1. So as a single fraction, we can write NP as this, given as OC can be written as OP plus PC. We can state that PC simply equals OC minus OP. So PC can be written as 8a minus 3b plus k all over k plus 1 multiplied by 2a minus 3b. And given as NP is a multiple of PC, we get this equation, and after multiplying this equation by k plus 1, we get this. And now that we have this equation, we can expand both sides of this equation in order to collect all the k terms and all the alpha terms onto either side of the equation. And by equating the coefficients of a and b on both sides of this equation, we get 2k, and that equals 6k times alpha plus 8 times alpha, and I'll call that equation 1, and 1 minus 2k, and that equals minus 3 alpha, and I'll call that equation 2. And using equation 2, we can state that 2k equals 1 plus 3 alpha, therefore k equals 1 plus 3 alpha divided by 2. And when we substitute this into equation 1, we have 2 times 1 plus 3 alpha all over 2, and that equals 6 alpha times 1 plus 3 alpha all over 2 plus 8 alpha. So 1 plus 3 alpha equals 3 alpha multiplied by 1 plus 3 alpha plus 8 alpha. So 1 plus 3 alpha equals 3 alpha plus 9 alpha squared plus 8 alpha. So after setting this equation equal to 0 by moving all the terms on the left hand side of the equation to the right hand side of the equation, we get 9 alpha squared plus 8 alpha minus 1 equals 0. And when you factorize that, you should get 9 alpha minus 1 multiplied by alpha plus 1, and that equals 0. So we can see that alpha equals 1 over 9, or alpha equals minus 1. And given as alpha must be greater than 0, we can state that alpha equals 1 over 9. So k equals 1 plus 3 times 1 over 9 all over 2. And if we simplify that, we get 1 plus a third over 2. 1 plus a third is 4 over 3. So 4 over 3 divided by 2 is the same as 4 over 3 times a half. So k equals 2 over 3. And since we stated that the ratio of BP to PA is k to 1, we can state that this equals 2 over 3 to 1. And when we multiply this ratio by 3, we get 2 to 3. So the ratio of BP to PA is 2 to 3.